This problem is about an amount of work done by certain number of people. Some people are men and the others are children. 6 men and 8 children complete a work in 10 days, and the same work is completed in 2 days by 26 men and 48 children. Then we have to find out how many days it will take for 15 men and 20 children to do the same work. In this problem, it is obvious that men will do work faster than the children. So key idea in the present problem is the rate of doing work. Man will do a work at a faster rate compared to the children. So first we have to define the rate of doing work. Rate of work. We do not amount of work by W. Number of people doing work be denoted by P. And time taken to complete the work, we denote it by T. Now P people are doing work W in time T. Suppose the amount of work is 24 units and this work is done by P people in say 4 days. Then amount of work done per day is obtained by dividing 24 by 4, and we get the amount of work done per day to be 6 units of work per day. We call this the rate of doing work, and this rate of doing work is by P people together. Rate of doing work by P people. The rate of doing work by P people is obtained by dividing work by time taken. Now this is the rate of doing work by P people together. We wish to find the rate of work done by every person. We suppose that all P people do the work at the same speed. None of the people is doing the work faster or slower than the other. All the people are doing the work at the same rate. So the rate RP is the rate of doing work by P people. We have to find the rate of doing work by a single person. The rate of doing work by a single person. Rate of doing work by a single person is obtained by dividing the rate of work doing by P people together by the number of people itself. We divide the rate of doing work by the number of people itself, and we get the rate of doing work by a single person, and I denote that rate by R. For RP here, let's substitute W by T and obtain R equal to W by T divided by P, and this finally gives us the rate of doing work by a person, W upon Pt. Now we address a simple question. What work will be done by P number of people in time t if everyone is doing the work at the rate of r? And this question is answered by the same equation. We just transfer P t on the left hand side here and keep W on one side. That is, we transfer Pt on left hand side and get Rpt equal to W. So this equation gives us the work W done by P people in time t at a rate of R. And this is the central equation in the solution of this problem. The amount of work done W by P people in time t at the rate R. Now we move to the problem. There are 6 men and 8 children. They both work for 10 days. So in the problem, we know that men and children will be doing work at different speed. So we will have to find the total work done by 6 men in 10 days and total work done by 8 children in 10 days. We will have to find these works separately. First we find the total work done by 6 men in 10 days. 6 men, 10 days. Work done by 6 men, let's denote it by Wm. And the number of people is 6. So for P we write 6. And R gives us the rate of doing work by a person. In the present case, R will stand for a rate of doing work by a man, and I denote it by Rm, multiplied by, in place of number of people, we write 6 men. And the time for which they do work is 10. So in place of t, I write 10. And I get work done by 6 men equal to 60 Rm. In the same way, we calculate work done by 8 children in 10 days. 8 children in 10 days. We use the same steps and find work done by 8 children, WC. WC stands for work done by 8 children, and this is equal to 80 RC, where RC is used for rate of doing work by a child, in the same way as we have used RM for rate of doing work by a man. Now in 10 days, 6 men do this work and 8 children does the work equal to 80 RC. So total work in 10 days is simply the sum of work done by 6 men plus work done by 8 children. We denote total work by W. Let's denote it by W1 for the reason that will become clear later. Wm is 60 Rm. So in the next step, we write 60 Rm. And Wc is 80 Rc. We write 80 Rc. So finally, we have got the work done by 6 men and 8 children as given by this equation. The second information in the problem is that when there are 26 men and 48 children, they do the same work in just 2 days, 26 men and 48 children. And 2 days. The equation that we just obtained gives us work done by 6 men and 8 children in 10 days. We obtain same equation, similar equation for 26 men and 48 children by using the same steps as before. So after following the same step, we will obtain the work done by 26 men and 48 children, which I denote by W2 as 52 Rm plus 96 Rc. Now, work done W1 and W2 are the same, just the number of men and children differ. Work done W1 represent work done by 6 men and 8 children, while W2 represent the same work done by 26 men and 48 children. So W1 and W2, these two amounts of work is equal. We write W1 equal to W2. W1 is 60 Rm, 80 Rc. In the next step, we replace W1 by 60 Rm plus 80 Rc. And we replace W2 by 52 Rm and 96 Rc. Now, when we transfer 52 Rm on the left hand side, it is subtracted from 60 Rm. We get 60 Rm minus 52 Rm. And we transfer 80 Rc on right hand side, and we get 96 Rc minus 80 Rc, and this gives us 8 Rm equal to 16 Rc. We divide both sides by 8 and we obtain Rm equal to 2 Rc. We found that the rate at which a man does work is twice as high as the rate at which children do work. Means the rate of doing work by a man is double of rate of doing work by a children. Now, we have to find the number of days that would be taken by 15 men and 20 children to do the same work. We have 15 men and 20 children. And we have to find time they would need to complete the same task. Again, we write total work done by 15 men and 20 children as W3. And using the same steps as before, we obtain work done by 15 men and 20 children in time t like this. 15 RMT plus 20 RCT. Now we have no value of time to substitute for, so we write time as T only. W3 T can be taken common, and we have 15 Rm plus 20 Rc. Again we substitute for Rm as 2Rc from this equation. And then we have 30Rc after substitution. Equal to W3. Now the amount of work is same. So we have W3 equal to W1 equal to W2. For W3 we write this expression T time this 30 Rc and 20 Rc gives us 50 Rc. So we write 50 Rct. RCT. Now W3 is equal to W1. We consider only first equality. We consider first equality. And W3 is 50 RCT. For W1, we write 52 Rm plus 96 Rc. Plus W1 is 60 Rm plus 80 Rc. We substitute for Wm 60 Rm plus 80 Rc. Again for Rm here we write 2 Rc. So it is 120 Rc. So we have 50 RCT equal to 200 Rc. Rc cancels from both sides and we have 50T equal to 200. And the time T taken by 15 men and 20 children is 200 divided by 50. And finally we obtain time T as 4 days. So 15 men and 20 children will complete the same work in the time of 4 days. So finally we have obtained the solution. To solve this problem, we have used a very simple ideas and simple methodology. The solution might look lengthy, but with more and more practice, you will be able to solve this problem with your own tricks in much less time. Thank you.